So we're assuming that you know object-oriented programming, services, and like single script architecture. So if you aren't familiar with these, then potentially this isn't the talk for you. But with that being said, we think this is going to be a really good talk. So I'm James Anand, and we also have presenting with us Trey Reynolds, Alex Balfrans, and Lucy Sweet. Um, so with that, we're going to talk over these 5 powerful code patterns. And with each code pattern, we're going to associate it with a Roblox game. So we're talking about signals, maids, promises, springs, and binders. And then we'll be taking questions about each of these in the devs code patterns channel in the Discord. So post your questions as you come up with them, and then they'll be selected for the end. So why these patterns? All of these patterns help deal with asynchronous and dangerous operations in Roblox, and then problems that we end up creating when we're using these patterns. So we have some really tricky problems in Roblox that these help solve. So like signals help handle user input, maids with memory leaks, promises with data stores and web requests, springs with animating things, and binders with streaming enabled and other decoupling of code. And inherently, all of these patterns decouple your code. And so the metric that we're looking for is how fast can you delete a module of code from your game? And all of these patterns help you do that. With that being said, I'm going to talk about signals for event-driven games. All of these patterns are used in these top games, but we're going to look at whatever floats your boat and to an extent, Winlight Bay for these signals. So first of all, you've probably seen signals before. You use signals to decouple your code, and there's several strong patterns with these signals. The caveat with signals is that signals may memory leak. So we're going to take a look at these signals here. The philosophy behind signals is really simple. You should observe the world, don't query it. Observing the world is something that signals do very well. So the way signals work is we've got a signal here, and for each event, we have a notification to each observable, and you can disconnect these. So if you've written a connect line of code in Roblox before, you've used signals. Roblox programming is very event-driven, and this is really good. So we use this all the time. The contract behind signals is pretty simple. When we connect to a signal, we give it a callback. Sometimes this is an anonymous function. You'll see it like on touched or on dead or something. Upon the connection, we get a connection object that we can then disconnect. So we can cancel the connection. And then when we write our own signal wrapper, we use a fire event that we write ourselves. But when it fires, then the signals will call each callback in its own thread. So signal-based code is something that looks a lot like this. We connect to the connection and we do work when something changes in the world, whereas querying is like a loop-based thing. And the signal-based code has several benefits to it. First of all, signal-based programming reacts immediately. So loop-based stuff will take a little bit of time to get around, in this case, half a second. You can also cancel connections at signals, which is a really, really good pattern. So maids are perfect for this. We'll have Alex be talking about that in a bit. And then the other thing is like errors don't propagate in signals. So in a loop-based code, you can have errors that occur and it'll stop your loop from executing. But in signals, the signal will continue to be connected and fired off even if an error occurs. So this helps decouple your code further. So in this case here, with the humanoid died event occurring 3 times, we loop and connect 3 times. If this was in a loop, we would only get 1 high here. But if it's in a signal like we have here, it'll actually error out 3 times and print 3 times. So that's pretty cool. And it'll print with this I. So there are some disadvantages to signals. First of all, there's a little bit more indirection. This can make stack traces harder to follow. They're also a bit more expensive to operate, but it's not as expensive as querying the world every frame. So you should probably still be using signals. And they can memory leak. So we want to disconnect all of our events. And this is the biggest problem that signals create. And maids help handle that. In practice, we have several ways we can leverage signals. And we're looking at whatever floats your boat here. So in this case, we've got this backput input control. And we're listening for the tab added and tab removed. These are custom signals we added. And what we do is every time this changes, we're going to call this update hotkeys method. And it's going to loop through all of the tabs, which we know just changed, and assign the correct shortcut to it if we find a shortcut. So, and we also, the really important thing here is we also call this update thing on line 60 when we initialize to make sure we initialize with all the correct values. So this helps bind the state of the tab control to this input control here. We also have a really common pattern with signals where we pass anonymous functions instead of named functions in. So in this tab request activate thing, in this backpack to tab adapter, we can do work on this anonymous function or on this backpack item thing in this closure. And we just listen to the activate event here. And then we do work when it activates. So this is also a really good way. You can avoid making classes using closures and signals. So this is really good. Custom signal-based code is another really common pattern. So one thing I really recommend is you use this like signal class here. And then when we activate or deactivate a signal, we can do work on it. So in this case, this is from Winlight Bay. We have basic key map controls. And what we're doing here is anytime the key map controls are activated, we go ahead and we add some haptic feedback and a little bit of camera shake, and maybe play some music or sound effect. And so what this does is it helps, even though we just created a signal here and this class is the one firing this activated, it is easier to decouple this feedback and have it only in one place by listening to the signal we expose in this key map control. And these activated and deactivated methods are also exposed for other modules to listen to.
The 3D structure of the hat and the behavior of the hat. So what does this mean? What does coding in the metaverse look like? Fundamentally, I don't think we know yet. What I don't think it looks like is a text editor suspended in 3D.
So we'll talk about remote events first. So a lot of people like to pass things through a single remote event, and they think this is a performance improvement or something. It really isn't. It is better to structure your code with remote events. And I really prefer putting remote events underneath existing objects like this, so you can resolve them. It's also really, you have a lot more context that way. So additionally with remote events, if you have a global remote event for like this reset service, I generate that with a constant. So you can see here, I'm getting this remote event name and I'm getting the remote event from that constant. So retrieving that on a client and a constant is usually the best way, is what I found. But in general, remote events per instance are really good. And then also you should really use value-based objects for replication. Value-based objects are really good. And attributes will replace these to an extent, but they don't exist right now. So for now, you should prefer value-based objects. And they expose a changed event. They replicate automatically. They type check for free. And they throttle replication to 60 hertz. So all these properties are really valuable. And the big thing is, even with attributes, you can use them without parenting them. So you can put them in your own code module and use them, and they expose a value that can be changed, and it will debounce all of the changes if it's the same value. So avoiding value-based objects is like a really bad idea. I tried this for several years and it didn't work out. So I found it's like really, really powerful to just use these. The other pattern we have here is bindable events. I don't use these directly because they recreate tables. So you can see here, it's serializing this table out, and we get a different memory address when we pass it through the bindable event. So this is really expensive because it has to go through Roblox's serialization system. Instead, what we want to do is we want to wrap this in our own custom implementation of it, so we don't recreate the table. So what we have is a signal class here. And what we can do is we can fire off changes. So in this case here, we have a dialog slider. And anytime it changes, we fire off the selection confirmed event. And one thing I like to do is output comment the values coming out of the signal so I can see what's changing. With that being said, signals have an issue. They can memory leak. An anonymous function can keep a signal alive, especially if it's connected to a Roblox instance that is now parented to something else. And so the Lua garbage collector will never collect your stuff. So the best practice is to disconnect all of your connections. You can call disconnect on them. There's also a destroy and clear all children method, which will disconnect all connections on the instance and then clear all children on all children instances. So what we do is we use maids to help leverage this. And so maids are really good here. So with that being said, you've seen signals before. User input comes from signals. Other things come in from signals. You should use value-based objects for replicating like constant values. And there are several strong patterns with signals. So leverage those. And memory leaking is an issue. So with that being said, here is Alex to talk about maids and how we can deal with those.
Thank you, James. Hey, everyone. This is Alex Belfans from Jailbreak. I'll be talking to you about maids. James just talked to you about signals. Signals are great. You should use them everywhere. I know I sure do. And maids help you use them better. So um, first, summary of maids. Maids make you think about memory leaks from the start. They encapsulate cleaning things up. They make state easier to manage, and they move cleanup code to the constructor rather than the destructor. So the main philosophy behind maids is a singular object to clean everything up. So to create a maid, first you'll require the maid class and then call maid.new on it, and this will return a Lua class, which has a function exposed called giveTask. And to give task, you can give functions, connections, or anything that implements destroy. So this can be a Roblox instance, all of which implement destroy, or a custom class, anything that has a destroy function. You can give this to a maid. So when you're ready to clean up everything that you've given to a maid, so that means, if it's a connection, it'll disconnect the connection. If it's a function, it'll call the function. Or if it's an instance or a class, it'll call destroy. You just call do cleaning on it. And this do cleaning has an alias called destroy. So you can actually, that's handy because you can just call destroy, which means you can give it to other maids. So you can have a maid clean up another maid because it has a destroy function. So maids in practice, let's look at where I use some maids in Jailbreak. So when you first start using maids, the most common use will be cleaning up signals. So here I have a region class, which exposes two events, on object added and on object removed, for whenever, for example, a player enters some defined region. And I give these events to a maid so that whenever the parent class, whatever instantiated this region, whenever I clean that up, it'll disconnect all those events so that we no longer are waiting for any signals from people entering or leaving an object, the region. And then on the right here, same thing, we have some signals being created. Here I'm actually giving the signal instance or signal class to the maid, which, as James said, is a little overboard, but it's good to be paranoid about this because destroying the event will disconnect all the connections it has as well. So if you know you're done with the event and maybe you forgot to put, add one connection to your maid, you can just destroy it and it'll clean it up for you. It's a good idea to use maids in an object. This is where they shine the most. So here I have a rocket launcher, and this gun.new subclass creates a maid, and then you see at the bottom, I'm using the maid. So I have this rocket world class, which handles the simulation of all the rockets in the rocket launcher. And here's an example of putting cleanup next to construction. So immediately when I create this simulation class for the rockets, I'm giving it to the maid so that when I call rocket launcher : destroy, this is going to clean up that entire rocket world simulation class. So this is an example of using maids within maids because the rocket launcher has a maid and the rocket world also has a maid, and I'm giving the rocket world class to the rocket launcher maid. You can also use keys in maids. So I talked about give task, but you can also just index them. And this is handy because here's an example in Jailbreak where we recently added helicopters, which can pick up cargo crates and you can carry them around. And I wanted to do certain things like crush the player or make a sound when it hits the ground. But for example, touching the player or certain other things, I wanted to actually know who the player that dropped it was. So one way was just to reconnect that touched event every time you drop the crate. And so with indexing maids, if a connection already exists, you see I do self.maid.touched. If one already exists, it'll first disconnect the old one and replace it with this new one. So that's super handy. It makes sure there's only one connection alive at a singular time. Maids for deferred action. So this is using anonymous functions you can pass to maids. So here in we have game modes in Jailbreak, and this one is the alien game mode. And when you drop the players, it kind of, it changes your outfit to an alien, does some other things, give you some items. And so instead of like making sure that I clean this all up, when I call destroy, I just right away, when I drop them into the game, this last function where I give an anonymous function to the maid, I make sure that I restore their inventory and reset their avatar. And so it's really nice just to see that, like, right when I change their avatar in this drop player function, I'm also restoring their avatar. So I don't have to worry about forgetting that. You can also do some slightly more complex logic. So here you can think about that rocket world class. I don't want to stop the simulation of all the rockets in the rocket launcher when I destroy it. So you can imagine this code being inside the rocket launcher destroy method. First, I wait to make sure all of the, like if there's currently rockets flying through the air, I wait for that rocket queue, to be emptied. And then I finally finish all the cleanup. Otherwise, I just destroy immediately. So maids can give you some really nice complexity for whatever you want to do. So maids, in summary, they make you think about memory leaks from the start. They encapsulate cleaning things up, and they make your state easier to manage. And they also move your cleanup code to the constructor rather than the destructor. And now I'll pass it off to Lucy.
Thanks, Alex. Hi, everyone. I'm Lucy. I'm a systems engineer at Adopt.me. A quick bit on, have I got control? I think I do. Oh, no, I've gone too far. Go back one. There we go. Okay, cool. So I'm a systems engineer at Adopt.me. I'm Lucy, blah, blah. So quick bit on yielding. Here we go. So quick bit on yielding. As behavior, yielding occurs on Roblox when you call a yielding method, which needs to get a result, but it might not immediately have it. So network requests, is in group, HTTP service, data store service, etc. It's pretty intuitive and easy to sort of hide in the background insofar as it will suspend your current Lua thread, but it will allow other Lua threads that are ready to run in the meantime while your one is yielding and getting its result. That can be quite useful and intuitive, except if you don't realize that some of your functions can stop halfway and other code can run in the meantime, it can cause some pretty nasty race conditions. And it can actually be quite hard to spot when things are going to yield. So for example, you may call out to a function that you don't realize is then calling a yielding method, or it may be a method that you don't even know yields, like isInGroup, for example, does not have async after it, but it does yield. Beyond that, yielding is just a behavior. It can't be represented, observed, interacted with. It just sort of happens in the background. So that can make concurrent operations and other things in that area a bit annoying sometimes. I've got a few examples on here. So wouldn't it be nice if there was something that did it for you? Well, sorry, gave you these sorts of abilities. Well, there is, and it's promises. So in brief, promises are a way to represent a task that will either complete or fail at some indeterminate point in the future. And by using promises, you not only get observability onto that task, but you get access to a lot of cool methods and patterns that you can use. So making a promise is pretty simple. This is insofar as the library written by Avera that's available on her GitHub. There are other libraries available, just not as good. That's my own opinion, though. So that's the one I'm going to be referring to in this presentation. So this promise here simply reaches out to HTTP service. It downloads a website, and then it completes the task by passing the website to this little function called resolve, which is pretty ubiquitous to what return would normally do in a Lua method. It completes the promise, and it sets the returned value to the value passed into resolve. Promises make yielding easier to use and harder to misuse. So it's important to note that when using promises, there's no yielding on the main thread unless you cause it somewhere else. So you're at a reduced risk of accidentally introducing some nasty race condition due to yielding. Beyond that, you can observe the state of your promises and your tasks, and you can check if they're finished, as well as assigning multiple callbacks to run for important events in them. For example, the promise completed successfully, the promise failed with some sort of error. So you can handle those a lot easier and more intuitively. So yeah, as I touched on a bit earlier, that promises give you access to useful methods. So I'm going to go over a few of them now, and only a few of them, and the rest you can look up in your own time though. So promise cancel because we have observability on these tasks, we can start to interact with them. So promise cancel gives you the ability to cancel a promise before it's completed. It can be really useful. For example, if you want to preserve resources by not executing code, you're no longer need it anymore. So cancellation is best effort, and there's no guarantee as to when that that task instantly stopping or anything like that. But you can say the library will do its best to halt it in the future. So here's some example code. It's not really great code, but it's an example. And then none of this code, for the record, in any of this talk is used in Adopt Me. So in this example, we have a yielding and pretty expensive function being called. When a player opens a leaderboard, we make a load of expensive calls. Let's say it's like order data source service. But what do we do if the user quickly closes that board? It would be a waste of resources to just load the whole board that nobody's going to be looking at. So normally we would end up just wasting all our data store quota because the function's been called now. You can't stop it. But we can cancel the promise in this case and preserve all our resources. So that's cool. Promise and then, it also takes advantage of the observability. It lets you subscribe certain callbacks to run in response to the promise executing successfully. So for example here, we've got that example from before, creating a promise that I used, where I made one that reached out to a website. And then after that, once that completes successfully, we print the content of that website straight out to the output. If there was an error here, this code wouldn't be executed at all. What would happen? Or sorry, the callback wouldn't be executed at all. If you want to hook into an error happening on a promise, you use catch. And if you don't hook in and it does error anyway, it produces a warn in the standard output of Roblox that you can see. So, and then calls can also be chained to run one after the other. So for example, here, our original promise is returning 1, and then we have an end call that adds 2 to that, and then we send that to print, and you can see I get an output in Studio of 3. So that's quite cool. So promise.all. Promise.all is a bit different from the others in that it's not a method on the promise itself. It's a method at the top level of the promise library. What it lets you do is it creates a promise that encapsulates multiple promises and you can treat them then as a single one. So when you add a load of promises to promise.all, that promise that you've created now that groups them all will complete if all of the promises under it do, and it will fail if any of the promises under it do. So that can be really useful. For example, if you've got a load of related tasks that you want to basically treat as one big group. So for example, here, I've got some example code of what it might look like in Adopt Me, where I have a load of different tasks I need to do before I can spawn a player into the game, loading their house, their money, and their pets, and things like that. And rather than listening to every single one individually and keeping track of all of that, which would be a pain, I just treat them all as a single promise, and I then have code to deal with them if it either completes successfully or if it fails with an error. And yeah, so in summary, promises make dealing with yielding and tasks easier by giving you observability and a load of really useful common patterns and methods, some of which I touched on here, but some at the bottom of the slide you can see that I've completely missed out, but are also really cool because don't have all the time in the world here. So yeah, so now I'm going to pass over to Trey to talk about Springs.
Thank you very much, Lucy. Okay, so hi, I'm Trey Reynolds. I'm from Silo Studios, and you might know my work as Axis Angle through Phantom Forces and other games. And I'm going to give an overview of Springs and demonstration of the pros and explain some caveats. So, okay, so where have we seen Springs before? On the left side, we have a Roblox Spring constraint, and it's attached between 2 parts, and that's just out of the box from Roblox. On the right, we have an off-road racing truck that uses springs and dampers, also known as shock absorbers, which is important to help the body glide over the rough terrain. And then in the middle is a use of springs that you might not have seen before or might not have noticed, but definitely seen. And we're going to be focusing on this use case. So in this case, we use springs to apply multiple control forces. So when you land on the ground, the gun goes down, but it tries to bring it back up through a spring. And then whenever you fire a bullet, the bullet will impart some momentum to the gun, and the spring tries to return the gun to its original state. So what are we really talking about? Springs are a second-order differential equation where the acceleration of a function is described by 2 forces, one resistive to the velocity and the other towards the goal position. And this is kind of confusing, and we don't have the 4 weeks we need to explain it. So we're not going to talk about differential equations. Instead, we're just going to focus on the concepts. So springs try to move a point's position towards a target position while limiting the point's velocity, and that's the big deal. And this general behavior can be applied to solve many different problems. And for this presentation, what we're really talking about is the use of MySpring module for artistically tuned physical animation. This module asynchronously updates itself separate from the rest of your code, which makes it really nice to use. Okay, so what makes Springs so great? They're good for twinning and animating, and it's intuitive for artists and has a lot of variety of behavior. The parameters are scale and variant, so you can use the same Spring parameters to work with really small numbers and really big numbers. It all looks the same. And they also work the same in any number of dimensions. So numbers, vector 2s and vector 3s or whatever, the behavior is the same. And we'll talk about C-frames later. Springs are really only good for linear spaces, but you can work around that. Okay, so how do springs work? Did we go? Okay, so in this picture, we have a black point mass, and at time t equals 0, it was at the green initial position with the purple initial velocity. And then at this point, we applied a spring to it. And so the spring is trying to pull the black point towards the green goal in the center of the spiral, and the spiral is the path that the black point will take. Okay, and so again, there's two forces acting on the black point, and we have the blue line, which can be thought of, well, the blue force, which can be thought of as like just literally a spring that's attached between 2 points. And then the red line is like a wind resistance force. Okay, so here are some different examples of different spring values. The speed damping is the damping parameter, and the speed is the spring speed parameter. So the initial velocity for all these is the same. And as we go to the right, we increase damping, and as we go down, we increase speed. And you can see that as we increase speed, the shape of the shape does not actually change. So in order to actually change the shape, you just increase the damping. There's more behavior here than we show. Okay, so in order to explain the benefits of using springs and show how one might implement them, we're going to write a vehicle follow camera. And to begin, we'll write some really basic code, which will keep the camera in the same position relative to the car. So at the top, we require resources, we get the car, and we define a camera offset, which is just where the camera is relative to the car. And then we set up our update loop on line 8, and then on line 9 and 10, we get the car C-frame and the camera C-frame. And then on line 13, we just set the camera C-frame. And on the right, you can see the result of this. So the camera is definitely functional, but it's a little stiff and unnatural. And looking at and then we can make it feel a lot better by placing a spring in between where the camera wants to be and where the camera actually is, if that makes any sense. Okay, so looking at our loop, we're going to have to make some changes. So the problem is if we try to directly spring a C-frame, it won't work very well. Springs only work in linear spaces, and C-frames are not a linear space. We know that C-frames are nonlinear because if you try to freely change any of its 9 rotation values, you don't get a new valid C-frame, you just get a wonky invalid one. So what we can do instead is work with the position and the Euler angles y, x, z, which are both linear spaces, because any possible position and angles combination will define a valid C-frame. Okay, so on line 13, we'll convert camera C-frame into camera position and camera angles using a conversion function. And then after that, we'll convert back into a C-frame to get our final camera C-frame. And then on line 23, we just set the camera C-frame again. And this is still working code. The end result is totally unchanged. Okay, so now that we've linearized our space, we're ready for a spring. We're just going to put it in between. So we'll require a spring module and define 2 springs. And when we make a spring, we need to tell it what kind of value to expect. And since both our position and angles are vector 3 values, we'll initialize both springs with vector 3s in the first argument. Okay, so now we need to make room for our spring code in the middle of our update loop. And first of all, our camera C-frame is no longer defined directly with the car. So we're going to change these names. We're going to compute camera C-frame goal and then derive the goal position and goal angles from that. And then quick aside, get position and angles from C-frame always returns angles within a certain range. And this is not what we want because it does not keep track of how many times we've turned around. So we include line 19 to fix this. Okay, and then on lines 22 and 23, we say spring.t equals goal, and this is setting the target of the spring to the value we give it. And then on line 26 and 27, we say value equals spring.p, and this just gets the current value of the spring and stores it into the local variable. So now that we have our camera position and camera angles again, we're finished. And one last thing, we never set the damping or speed values of the springs, and this is because I added some code that will read values from some value objects in the workspace so that we can play around with the speed and damping in real time. And so now we'll watch a video. Okay, so here's basically the resulting product. Right now, the damping and speed are both set to 1, but we can increase the speed constant to like 30. And you can see it'll be much more closely coupled with the car. And so we're going to set this probably to 15. And then if we, or no, sorry, 0.1. So now it's really slow and you can see that it has a really hard time keeping up. But a good value is typically like 15. And then if we play around with damping a little bit, if we set it to 0.5 and run off the ramp, you'll see that the camera it has a little bit more bounciness, and it'll bounce a couple times after the car lands. So it kind of maintains momentum in the world. And then, yeah, so if we set the damping to be really slow or be really low, it's gonna really wobble a lot. And then of course, a damping of 50 will be really resistive to change. So even though the speed is 15, it's not gonna be very coupled with the car. But a good value is like typically 0.8. In between 0.5 to 1. Okay. So springs in summary, springs are physically based and feel good. They're naturally intuitive to humans. And springs are also highly tunable through their speed and damping parameters. And also the spring implementation is solved. So it only updates when you ask it for a value or try to set a target or value to it. And this means it is performant and stable no matter what numbers you throw at it. And because it does not require you to update it, it's a lot cleaner. Okay, so now back to James Onan, who will present binders.
Cool, thank you, Trey. So binders are this really less common pattern in Roblox that we have in games. So there's not as many games using this, but I think it's a really powerful way to program in Roblox. The idea behind binders is really simple: to bind behavior to Roblox's data model. And so what we do is we can bind Roblox objects or Lua objects to Roblox objects using collection service, and we can use binders to program streaming enabled. And binders really combine with other code patterns to get really good behavior. And the philosophy behind this is that Roblox is our source of truth. So why do binders work? Collection service. So if you haven't used this before, you definitely should be. Collection service replicates with instances, and we have two methods or two signals that we can listen to that are really valuable. We have a get instance added signal and a get instance removed signal. And these fire when an instance comes in with a tag and comes out of the data model. So this also includes when stuff streams in and out. The way we interface with this, because tags are not integrated into Roblox Studio, is we use Tiffany's tag editor right now. And you can just define tags. So the contract behind binders is really simple. It takes two things: a tag name, so in this case ragdoll, and a class to construct, our ragdoll class. And we have one on the server and one on the client. This is just the server binding. So every time we tag something with the tag name, our class is constructed. And every time it's untagged, the class is deconstructed. When it constructs, we call the .new method. The first argument is the class, in this case, the humanoid. And we call destroy just with like no arguments. So it gets destroyed. So you can see here with tags as our source of truth, when we tag this humanoid on the client with ragdoll, it ragdolls the client. And when you untag it, it unragdolls. And a lot of things are changing here. So when we ragdoll, we change the camera, we change the GUI showing, we show this little thing, but our source of truth here is just the tag on the humanoid. So this is really an inversion of control back to Roblox, and this is really good. And you can see here, we are on the server, we'd be constructing this class. On the client, we'd be constructing this class. We set up some stuff here. So the philosophy behind this is really simple. We're moving the source of truth back to Roblox. And this is really good. So why do we want to use binders? We want to make it easier to program streaming enabled games. We want to query Roblox's data model information, and we want to make it easier to test. And I guess there's an added benefit here too, where your builders now have an ability to interface with your game and add more content without a programmer being there. So all in all, there's a lot of patterns with this. The first one that's really good is querying Roblox's data model. So with binders, we can search up and down Roblox's data hierarchy for bound objects. So in this case, we have a compass waypoint. It's actually an attachment. And we first search the attachment just for a value-based object for the icon name. And if we can't find that, we search for a location in the hierarchy. And if we're underneath a location like Windlight Bay, which is the game we're looking at here, then we can pull the icon key from the location just by calling get icon key. And that can do who knows what. We don't really care. We just get the icon key back. Another example is this camera drone control. So in this camera, if you're flying the camera drone in Windlight Bay, you can go search. What we do on the server is we look underneath the camera drone object for any bound camera drone controls, and we just destroy them to stop all of the controls. And destroying those objects removes control from the player. So this is just a really powerful way to interface with Roblox, because now that the control isn't there, there's just no control. It replicates back to the client, it gets unbound, and we can remove the controls on the client. So Roblox is our source of truth. Another common pattern is binder groups. So we can add behavior to the game just by tagging it and adding it to a group. So what we have here is a trigger. This trigger bubble here is tagged with trigger, and it's kind of pointing back to the ATM. So we can reuse the same GUI everywhere because it's kind of the same. And what we do is we add the ATM to the trigger list here. And then whenever that activates, the ATM just gets a call, and we just bind the ATM with an ATM tag. So this is just a really nice way to interface it. And of course, the ATM has a method called onTriggerActivate, and this is just a type check to make sure that exists. So another really common pattern is updating things that are tagged in the game. So just a really simple loop. Let's say we want to go update all the trees, and we're doing this every like 10 seconds or something. What we can do is we can iterate over every single tree generator in the game and call update maturity on it. And then in the tree generator code, we just have a method called update maturity, like exactly what we want it to do. And then we can do some math on dates and stuff to figure out how much it should have grown. And so this is another really strong pattern, whereas if you didn't have bound objects, you would have to go look up that object some other way. And then finding that list could be very expensive. So this lets us cache a ton of values and do other things with that. Another big thing is fast editing in Roblox. So what we have here, it's lagging a little bit, but here we go, is we've got a flag tag. And when you tag stuff in the game, it just binds that behavior immediately. So when we have builders like messing with flags or something, what we can do is we can have them bind the flag while the game is running and see what happens when that tag gets occurred. And so by doing this, we're able to very quickly iterate and test on different builds and other things that we do in the game. So it lets us test quickly, both as a programmer and as someone who's making tools for other people in your team to be working on. So binders are really valuable in that way. Other common patterns, we can leverage the past patterns that we just discussed to work with binders in really powerful ways. So an example here is this model transparency effect. We're listening to all of the children and descendants, and we're saying this model transparency effect is on a model. And for each item in the model, decals or base parts, we're going to set the transparency on them. Whenever they get added or removed, we're going to remove that transparency modifier. And we're also going to update every time it updates. And so by using signals here and listening to descendant added and removed, we can now have this model always be transparent when we want it to be. And we can use this to hide objects, in this case, to fade objects in and out of the world. Another really common pattern is using maids. All of my bound objects tend to have a maid in them, just for easy cleanup because destroy is called. So this is just the base object I inherit from using object-oriented programming. And it has a maid, and it also has an object that I just give it. And that's the object passed in from the binder.new argument. So these exist for the maid exists for the lifetime of the object, and it gets cleaned up. And that's just a really good pattern. Promises are also really good. So if you remember in the signal talk, I was talking about how I parent all my signals to objects. Well, we can use a promise to promise that that remote event will exist. So we promise the remote event. We cancel the promise if the object streams out. So if the maid gets cleaned up, and then we can get the remote event and fire the server only while this is valid. So this works really well for one-off instances. It doesn't work well for stuff that comes in and out on the fly. For that, you need to use signals. But it's really good for static resources like this remote event here. So in summary, binders are a really good way to bind Lua objects or functions to collection service tags. It makes testing easy. You can use this for streaming enabled because stuff with binders basically works out of the box with streaming. So you don't need more control with streaming. All you need is to switch your source of truth to be Roblox instead. And then you can combine other patterns with binders to get really good behavior. With that, this is 5 powerful code patterns. This slide deck will be shared after the presentation, hopefully with links to the code for sure, and then hopefully with the questions we're about to answer. With that being said, I'd like to transfer this over to Hannah to help moderate questions.
Thanks, James. We actually don't have any time for questions, so I'm going to ask the 4 panelists to go into the Discord channel and answer questions there. So please post your questions back in that Discord channel. They will be there answering any questions. Again, that's dev code patterns in the RDC server. But we will see you guys back here in 10 minutes. for a talk from Sean on building worlds for game performance. But otherwise, thank you to our 4 panelists. We'll see you at RDC. Bye, guys.
Thank you so
Thank you very
much.
much.
Have a good day.